So this video is just a little bit more on exponential functions, particularly graphing them and finding out some properties about them like domain, range, intercepts, and asymptotes. So my parent function for an exponential function is going to be f of x is equal to 2 to the x. Okay, so what does that look like? Well, if I plot a few points, so when x is 0, I know that 2 to the 0 will be 1. When x is 1, 2 to the 1 will be 2. When x is negative 1, 2 to the negative 1, I remember that with negative exponents, I flip the base, so it'll be 1/2. Okay, and then if I connect these points, I'll have something that looks like this. Okay, so it should actually go through the point 2, 4 as well. But my graph there is like this, so you can see it's growing. This is called exponential growth. So of course, as my x values get larger and larger, this will start to increase and get more steep as it goes up. So the domain of my function is, I can choose any values for x. I don't have any problems, so I am going from negative infinity to infinity. The range, however, is I can get really, really close to 0. So you see here, this is going to get really, really close to 0 as I choose x is more and more negative. So like 2 to the negative 1,000 will be 1 over 2 to the 1,000. So it will get really close to 0 but never actually reach it. So my range is going to be from 0, not including it, up to infinity. Okay, and my intercepts, I only have one intercept. I have a y-intercept here, which is at 0, 1. And then my asymptote, so because I can never actually reach y equals 0, then I have an asymptote at the line y equals 0. Okay, let's check out just the basic general equation. So I have f of x is equal to a to the x. So we've seen this before where a is the base and x is the exponent. So here a must be greater than 0, so non-negative. It also must not be equal to 1, otherwise it's trivial, and x is in the set of real numbers. So everything that we've seen so far, we've only been dealing with real numbers anyways. So if I choose my a value to be, if my a value is greater than 1, then I'm going to have exponential growth. Okay, so it'll look like what we saw before where you're growing like that. If my a value is between 0 and 1, so if it's a fraction, I'm going to have exponential decay. So what that looks like is that I'll flip it, and as time or whatever, as the x values increase, my function will decay. Okay, so some basic properties of it. For as far as transformations go, if I want to transform or translate the function up or down the y-axis, so if I want to do a vertical translation, what I want to do then is I'm going to have some value added outside of the x's, so plus some value here. So this will shift my graph up or down depending on whether this is positive or negative. Okay, and then if I want to have a shift in the horizontal shift in the x's, then I have to have my shift up here with the x. So this would be moving the graph 1 unit to the left. And I can also flip over the y-axis. So if I want to flip over the y-axis, then that will look like this. I'll change the signs of my x's, and that'll take me over the y-axis. Okay, another important thing to note too is that we can have a base e. So you may have seen this number before. It's equal to something like 2.781. So it comes up a lot, and it's the base of the natural logarithm. So that would look, if you were to graph e to the x, it would look similar to the parent function that we graphed 2 to the x because it's pretty close to 2, but it would grow a little bit faster. Okay, let's see a couple of examples. Okay, so I have f of x is equal to 1/3 to the x plus 1. So this 1/3, because it's a fraction, I know that I'm going to have exponential decay. So it's going to be decreasing as the x values increase. And x plus 1, that means I'm going to be shifting 1 unit to the left. Okay, so let's just do a quick table of values to kind of see what's happening here. So when x is equal, so we have x and f of x. When x is equal to -1, I'll get -1 plus 1 is 0, so 1/3 to the 0 will be 1. When x is equal to 0, I'll get 1/3 to the 1, which is just 1/3. And then when x is equal, let's go pick -2 as well. When x is -2, I'll get x, or 1/3 to the -1, which would be 3 to the 1, so 3. So if I plot those points and keep in mind the basic shape of my parent function, of my exponential function, I have the points -1, 1, 0 and 1/3, and -2 and 3. So I can see that my function is going to look something like this. Okay, so my domain again is I can choose any values for x from -infinity to +infinity. My range, I do have that asymptote still. I didn't shift up or down, so my asymptote is still at y equals 0. So I'm going to approach the x-axis the further out I go to the right, but I'm never actually going to touch it. So my range is going to be from 0 to infinity, but not including 0. My intercepts, I have my 1 y-intercept again, which is at 0 and 1/3. I found in my table of values up here. And my asymptote is still the same as a parent function, is y equals 0. Okay, so let's see one more quick example. Okay, g of x is equal to 2 to the -x plus 1. So in this one, I have a shift. I'm going to shift up 1 unit. And this -x means I'm going to flip over the y-axis. Oops. And it has the same base as my parent function. So what I'm going to do is I'm going to start with my parent function that I had originally in the very first slide. So it looked something like this. So the first thing I'm going to do then is I'm going to flip the function over the y-axis. So I'm going to mirror it onto the other side. So this point will stay the same, but then this point will come here, and so sorry, this point goes over to there, and then the point 2, 4 will become -2 and 4. So I'll be going like this now. Okay, so that's just the flip over the y-axis. And then I also want to translate this up 1 unit. So I do want to shift this up 1 unit. So my graph then is going to end up, so this point here on the y-axis is going to go from 0, 1 up to 0, 2. This point here is going to go up to here, and this point up to here. So I'm going to get my graph looking like this. Also, my asymptote shifts as well, so I had an asymptote here after I had just done the flip, but once I did the translation up, my asymptote is going to move up to here at y equals 1. Okay, if you wanted to see this with a table of values as well, you could choose a few values for x, and then you'd see that if you plug them in to your function, so like if I choose 0, well, 2 to the 0 is 1, plus 1 is 2, so I should have the point 0, 2, which I have right here, which is good. If I choose x is equal to -1, I'll have 2 to the -1, so 2 to the 1, which is 2 plus 1 is 3, so I should have the point -1, 3, which I do, which is there. So it looks like it's working out, and it'll follow this basic shape. So my domain is still -infinity to +infinity. I can choose any values for x, no problem. My range, however, changed, so my asymptote moved up to 1. So my function will approach 1, y equals 1 as far as x goes out, but never actually reach it. So I can go from 1 is the lowest point, almost 1 is the lowest point, up to +infinity. My intercepts, I just have the 1 y-intercept again, which is 0, 2, and my asymptote shifted up to y equals 1. Okay, that's it. Thanks for watching.